Hello friends, in this video I will discuss about the quasi aromatic compound and homoaromatic compound and normal aromatic compound. And there are so many non-aromatic, anti-aromatic. I will give different types of example, and in aromaticity I already provide you a video lecture in which aromaticity, non-aromaticity and anti-aromaticity only discussed. Now in this video I will discuss properly quasi-aromatic compound, homoaromatic compound and non-aromatic compound. Okay, and there is a rule of polycyclic aromatic hydrocarbon which will be aromatic and which will not be non-aromatic, by which we can determine. This rule is known as Craig's rule, and for aromaticity there was a Huckel's rule. Okay, so there is a new rule, Craig's rule. Craig rules says that or states that about the aromatic and non-aromatic characteristic of polycyclic non-benzenoid molecules. Non-benzenoid, that's mean which is not benzene-like structure. In aromaticity, in my first lecture, I clearly say that benzene and its like structure, okay, which is determined by Huckel's rule. Now, non-benzenoid molecules and polycyclic molecules, okay, which is aromatic or non-aromatic, I will discuss it. Now, which have C2 axis, that's mean non-benzenoid molecules which have C2 axis, and the number of double bond if it is n, then if n minus 1, if it is odd number, then it will be non-aromatic compound, and n minus 1 if it is even number, then it will be aromatic compound. Okay, this is the condition. Now the condition is that it is polycyclic because there is a cycle, so in this compound there is two cycle, one is 5-member ring, another is 7-member ring. Okay, so total double bond is 1, 2, 3, 4, 5. So total double bond is 5. So value of n is 5 here. Minus 1. So it is even. This is even number. Since n minus 1 equal to even, hence this compound is aromatic compound, and there was another rule because there was a C2 axis. So this compound contains a C2 axis. So this is a aromatic compound, azulene. Okay, this compound is aromatic compound. Now what about this? What about this? This is also a polycyclic. This is not benzene-like structure. There is no 6-member alternative double bond containing cyclic compound. No, this is not a benzene-like structure. Non-benzenoid molecule is this, and it contains, again it contains a C2. If we C2 means if we rotate 180 degree, then it will remain same. Okay, so just if we rotate this about 180 degree, that means C2, so this will not change. So total number of double bond 1, 2, 3, 4, 5, 6. So 6 minus 1, it is actually 5, and this is an odd number. So this compound must be non-aromatic compound. It will not be aromatic compound if n minus 1 is even, then this will be aromatic, but here n minus 1 is odd number, hence this compound is not aromatic compound. Clear? It is look like a aromatic, there is a conjugation, but it is not aromatic, okay, from the Craig's rule. Now there is another compound, there is a 5-member ring, so it is also non-benzenoid molecules and it contains also a C2, also there is a C2, okay. This is also polycyclic because greater than one cyclic compound is known as polycyclic. There is a cycle, so 1 2 3 4, there is a 4 double bond, the 4 minus 1 is equal to 3, which is an odd number, so it is also a non-aromatic compound, okay. So in this way we can identify which is aromatic or non-aromatic from the Craig's rule, and the compound must be non-benzenoid molecule, okay. And for benzenoid molecule it is always aromatic, no problem. Now what is homoaromaticity? The homoaromaticity is the special case of aromatic compound in which conjugation is interrupted by a single sp3 hybridized carbon atom. Here we can notice this is sp2 because there is a 3 bonds, 1 2, and there is another hydrogen, okay, and one is a plus, so this is sp2, no problem. So this is conjugation, there is a conjugation, but this sp3 interrupted this conjugation, okay. So but thermodynamically it is stable, there is a resonance, so in this way it can resonance, it gives a resonance structure, but this sp3 carbon just interrupted this resonance, but this is a thermally stable cation, okay, hence this compound is known as homoaromatic compound. And what about the tropylium cation? Tropylium cation C8 H9 H plus, okay. So there is a like a conjugation, but this sp3 carbon, there is a hydrogen, so this sp3 carbon just interrupted the conjugation, but this type of conjugation is thermodynamically stable. This is a 7-member ring, okay, like a 7-member ring, but it is not a 7-member ring, but this type of conjugation is also sometimes stable, so this tropylium cation is also a homoaromatic compound, okay. What about the quasi aromaticity? The quasi aromaticity, it is a aromatic compound which involved charge delocalization. That's when this is charge, it can delocalized, okay. That's mean charge delocalization which is present in the ring, that is the compound where negative or positive charge is a part of Huckel rule. That's when যখন a negative or positive charge like this, it is negative, so this is a quasi aromatic compound because this negative charge can delocalized in this way, okay. So this is a quasi aromatic compound. This compound is also quasi aromatic compound because there is a charge, this positive negative charge can delocalized, okay. So this is also a quasi aromatic compound, And from this structure, when it goes to a resonance structure that's been in positive and negative charge, the dipole moment will be increased, and this is a very stable compound, no problem, though it contains positive negative charge, but it is a very stable compound because this is a quasi thermodynamically stable, is resonance stabilized, and it contains high dipole moment. Now, what about this? This compound, it contains 1, 2, 3, 4, 5, that's mean 5 into 2, 10, okay, 5 into 2, 10 pi electron, so it maintains Huckel rule, no problem, but it is not quasi aromaticity, it is direct aromatic compound because it maintains the Huckel rule. And this is a cyclic alternative double bond, maintains 4n plus 2 pi electron, okay, no problem. But when this hydrogen is trapped by some base, then it will be, this carbon will be negatively charged. Then what happened? This compound is interesting compound. You may consider that this will be here, then this will be here, there may be a resonance stabilized. But remember that this compound is very stable compound. From this compound is more stable because this negatively charged ion, this negative charge cannot participate in delocalization. Okay, this negative charge cannot participate in a delocalization, and it again is maintained the aromaticity because this negative charge is not the part of 4n plus 2 pi electron. 1, 2, 3, 4, 5, that is pi electron. We may think that this negative is the part of aromatic compound. No, this is very much planar structure, stable without this negative charge. Hence, this negative charge is not delocalizing this pi bond. So it is aromatic. It maintains 4n plus 2 pi electron rule, that is Huckel rule. This without this negative charge. If we consider this negative charge, then it will be 4n pi electron, and it should be non-aromatic, but it is not the part of this ring, clear, and it is very stable compound. Okay, so what is this? This is oxoanilinone, there is a bond. So this is also a aromatic compound. This is also a aromatic compound. How? This can participate in localization, delocalization, or this can participate in this way. So there is a delocalization of a pi electron. This lone pair can act as a pi electron. And what happened here? There is a double bond. Sorry. There is a double bond. So if we consider this double bond is like a plus minus. If it is minus, then it is plus, because if we consider if this bond is break in this way, then it will be plus and it will be minus, then this part is aromatic. This part will be aromatic because this minus can readily go to resonance, but it is not aromatic. Okay? And what about here? What about here? This part is aromatic and this part is also aromatic, because when we consider this bond is single bond and there is a positive and this is negative, then what happened? What happened? This is 6-member ring, this is 2-member ring, it maintains Huckel rule, so it is aromatic part. Clear? Now, there are some special compound. There are some special compound which is also aromatic. It contains heterocyclic compound, atom in the cycle, like boron. If we consider this type of compound, okay, this is also a, though there is no electron, but it is a aromatic compound. This is aromatic compound. Okay, this is special type of aromatic compound because boron has a vacant p orbital. Okay, so this hydrogen can readily transfer here, and this can be localized in this way. Okay, there will be plus, this hydrogen can be just move. Okay, and if we consider like this, that's mean if we consider there is a double bond, if I say that okay, then this compound is also a aromatic compound. Clear? So this type of compound is special aromatic compound. So this is about all aromatic. This is my second lecture. So please, to see the first lecture, there are so many examples in the first lecture: aromatic, antiaromatic, homoaromatic, okay, compound and their rule and regulation. So please go through this lecture and subscribe this channel to get more update about all types of chemistry. Okay, thank you.